Today we're going to talk about tree diagrams and fundamental counting principle. If you are asked to list the different combinations, you must create a tree diagram. A tree diagram may be created vertically or horizontally. The set of all possible outcomes of a random process is called a sample space. So if I'm wanting to talk about grading assignments and do red pen or red pencil or red marker, so there would be three outcomes, because these would be my sample spaces, and there would be three of them at the bottom. So there would be three ways that I could grade papers. All right, example one. At Marble Slab, you can order vanilla, chocolate, or strawberry ice cream. So there's three flavors of ice cream that I can order. I can order them in a cup, a sugar cone, or a waffle cone. I want to list all the different combinations you could order. So we want to create a tree diagram vertically. So we've got vanilla, we've got chocolate, and we got strawberry. Now there are three different types of cones that I can put them in. I can put it in a cup, I can put it in a sugar cone, or I could put it in a waffle cone. For the chocolate, I could put it in a cup, I could put it in a sugar cone, or I could put it in a waffle cone. For the strawberry, I could put it in a cup, a sugar cone, or a waffle cone. Now, I want to know the possible outcomes. Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 different outcomes that I could get for the ice cream. All right, you will roll a die and flip a coin. List all the different outcomes. Create the tree vertically also. And it doesn't matter if you create it vertically or horizontally, but let's go ahead and create it vertically this time. Last time we created it horizontally. All right, so on a die, you have 6 outcomes. You have 1, 2, 3, 4, 5, 6. Those are all the ways I can roll the dice. Now for the coin, I have 2 choices. I have a heads or a tails. I could get a heads or a tails, heads or tails, heads or tails, heads or tails, heads or tails. We're going to count. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So we have a 12 total sample spaces on a coin and 1 dice. All right, we're going to flip 3 coins, a dime, a penny, and a nickel. List all the possible outcomes. And we're going to do this one horizontally. So we have a dime. For the dime, we could get the head. We could also have another dime, or the same dime, or we could get the tail for it. So we could get the heads for the dime, or we could get the tails for the dime. Then we have a penny. Well, on the penny, we could get, the penny could be a head, or the penny could be land on a tail. For if we had a dime tail, we could get a penny heads or penny tails. And we also had a nickel. Well, we could get a dime head, penny head, could get nickel head, or we could get nickel, tail. We could get nickel head here, or we could get nickel tail. Here we could get a nickel head or a nickel tail. Here we could get a nickel head or a nickel tail. So now we have 1, 2, 3, 4, 5, 6, 7, 8 sample spaces for possible outcomes. Because I could get a dime head with a penny head with a nickel head, or I could get a dime head, penny head, nickel tail, and so forth. All right, let's look at this one. Now we're going to do the fundamental counting principle, or the FCP. It is used to find the number of possible combinations or outcomes. To determine the total number of outcomes possible, multiply the total number of each situation. So if I have 3 colored shirts, 2 types of shorts, and 1 pair of shoes, I would go 3 times 2 times 1, and it'd be 6 outcomes. So we have Jack came in red, or excuse me, jackets come in red, blue, or green, and in sizes small, medium, and large. How many possible combinations are there? So we have 3 colors that we can choose from times 3 sizes we can choose from. 3 times 3 is 9. So we have 9 combinations or outcomes that we can get. All right, Fuzzy's Pizza, you can order your pizza with thick, thin, or hand-tossed crust. They have small, medium, and large sizes to choose from: cheese, pepperoni, sausage, hamburger, Canadian bacon. How many different combinations of pizza can you order? Well, first of all, we know we have 3 types of crust. Okay? Then we have 3 sizes. And then lastly, we have 1, 2, 3, 4, 5 toppings. We're going to multiply 3 times 3 times 5, which would be 45 combinations. Now, you can make your tree diagram to verify this, but that's going to be one big tree diagram. A test consists of 5 true or false questions. How many outcomes are there? Okay, so if we have a test that has 5 true and false questions, well, we have question number 1, which would have 2 choices, true or false. We have question number 2, which would also have 2 choices. Then we have question number 3, which would have 2 choices. Question number 4, which would have 2 choices. And question number 5, which has 2 choices. So we have 1, 2, 3, 4, 5. Okay, so that would be 2 to the 5th power, which would give us 32 outcomes. All right, one last one. We have 4 coins that are tossed. How many possible outcomes are there? Well, first coin, we have heads or tails. Second one, we could get a heads or tails. Third, we could get a head or tails. And the last one, we could get a heads or tails, which is the same thing as 2 to the 4th power, which would give us 16 outcomes. Now, make sure When you see like 2 to the 4th power, you don't go 2 times 4, which is 8. Remember, that means 2 times 2 times 2. All right, let's see how you can do. See what we can discuss tomorrow. Talk to you later. See you later.